Hello, everybody. Dear Hyper D, I think we are becoming good friends, you and I. You make things quicker, and my machine never falls over without a RAM issues because you got too greedy, so thank you. But could you please tell me how much RAM you would actually like to eat? Are you hungry? I would like to feed you to make you strong and fast, but because you're always so polite, I never know if you want more. How can I find out? If for my usual requests, you look at it and decide, nah, looks way too big for the space I got, I'll use the disk instead. If you only told me somewhere, I would feed you better. And if you told me you want more, can you tell me how much you would like?
Hello, everybody. My name is Raul.
My name is Max.
And the letter we just read out loud to you, was delivered to us and signed a Hyper user. And the reason we read it out loud is it's part of our motivation into going in this talk. So just to set the expectations a little bit, it's a 1-hour talk. We're going to try and wrap things up in 45 minutes so we can have 15 minutes in the end for Q&A. And hopefully at the end of this talk, we can empower you to be better able to deal with performance and Hyper in general, so that you can have the tools of figuring out what is slow, why is it slow. We'll also try and share some of the knowledge we've gained by working these past 2 years on performance with Hyper, some of the issues customers have faced, and just general build parallels between performance and Hyper. So the first thing you have to ask yourselves when you're thinking about is when am I actually using Hyper, right? Because if I want to optimize the performance for my Hyper extract, but I'm not using Hyper at all, then there are better talks which can handle that in general. But first, a quick commercial break. This is our logo, so to say. So if you see if you see people walking around with the database logo, you will know that that's us, so you can feel free to ask us about Hyper stuff and just like general questions, or just come and say hi. We're pretty friendly. We're based in Germany, in Munich, which is why we also have that quality made in Germany thing at the corner. And just as a little bit of a motto, Hyper die Datenbank, which basically means Hyper the database in German. Right? So let's get back to it. When am I using Hyper? So we released with 10.5 at the end of 2017. And the first use case when you're actually using Hyper is when you're directly connecting to a Hyper extract, right? You recognize those, they're called .hyper files now. If you're using 10.5 or newer, you are also using Hyper if you're connecting to a TDE file, because Hyper can read those as well. The second use case, which you might not have known about, is when you're connecting to Excel, CSV, or text files. Tableau also, behind the hood, creates a Hyper extract, and will use that to give you the results of your analysis. This is mostly because Excel, CSV, and text is not as easy to query as something more structured like a Hyper file. The third use case is cross-database joins. So if you are connected to multiple data sources, you have to pull in all that data and merge it somewhere. That will usually happen in Hyper. And the fourth use case is advanced applications with Hyper API, or the newly released Hyper API, or the old Extract API. So basically, when you have a viz and you know that you're using Hyper because you're in one of those 4 cases, well, maybe not the fourth one because that one doesn't use Tableau directly. What basically happens is all those pills you have there in columns, rows, filters, or marks, they'll get translated into SQL queries, which are then forwarded to Hyper. And the language of Hyper is SQL. So you ask Hyper SQL queries, and Hyper gives you responses to that. There are some related sessions we wanted to go through. Just real briefly, there are some Hyper API related sessions. There are a lot of Hyper API hands-on trainings. We just found out today that we'll have a third repeat of this because apparently it's very popular. So we expected 2 first. I think we already had a couple of these. And there was also a research talk earlier today.
So Hyper, like Raul said, has been released end of 2017, so approximately 2 years ago. 2 years in software development, that is a long time. And since the initial release of Hyper with Tableau 10.5, we have been constantly focusing on optimizing the performance in so many use cases. And we are so focused on performance, we have a set of several thousands of workbooks that we use to track the performance over each release to make sure we do not regress anything. And there are 20 heavy hitter customers amongst the customer workbooks amongst those that we have collected and that we are tracking since Tableau 10.5. And here is how they have improved over time. So on the very left side, we see the geometric mean of execution times of those workbooks, of hyperquery times of those workbooks, from 10.5 on the left side until 2019.3 on the very right side. And we see that on those very, very heavy hitter workbooks, those are really complicated workbooks, we are now performing 3 times better than in Tableau 10.5. That is an achievement from our Hyper team and from the Tableau integration team. And our conclusion that we would like to draw from that is, when you have a performance critical workbook and you struggle with it, then just try it out with the latest version of Tableau and Hyper. There is very, very likely something that our teams have already done to improve the performance without a need for you to change anything on that workbook. How did we actually do those performance improvements? And at first, I would like to say a very, very big thank you to all of the customers who shared their troublesome workbooks and extracts with us, because without your support, it would not have been possible for us to track down all of these performance issues. So thank you, and we hope that we can keep this collaboration up in the future. And if we want to get a bit more technical, so we don't want to go into detail about that, if you're interested, you can grab us in a break. So the technical list of what we did is we optimized the contains function, since we saw that is heavily used in a lot of performance-critical workbooks. We implemented a query fragment deduplication. We implemented string optimizations and fastpath for collations. We spent hours reading assembly code to optimize some of our hot loops. We implemented final locking to improve parallelism. And that all sums up to German engineering, which some people might equate to magic, if you want. So Tableau and Hyper, they are designed for each other. They work really, really well together. But sometimes you have that one workbook where you wish it would be a little faster. Everyone in the company knows it. It takes some seconds to open, but you don't really know what to do about it to improve its performance. So you're asking yourself the question, what can you actually do to make that workbook faster? And since we're now talking about the Hyper aspect of the workbook, we already made sure that we are using a workbook that uses Hyper, but we also need to find out that Hyper is actually the performance bottleneck. And to find that out, we recommend to use the performance recording. You can access that in Tableau under Help, Settings and Performance, Start Performance Recording. And when working with a Hyper workbook, it's tremendously important to disable the external cache beforehand, because that way the queries are really executed by Hyper and do not hit Tableau's caches, which would hide possible performance problems. And this is the result of a performance recording. We assume that most people of you are already familiar with how it looks like, but let me just walk you through it. On the very top, you see 3.79. That is the total workbook open time. In the middle, you will see a waterfall diagram of the events that occurred after each other. And in the very bottom, you see the events sorted by their execution time. So you see in this workbook, green marks the executing query event, and that is the time that for this workbook has been spent executing Hyper queries. And we see that this is 0.34 seconds. So if we want to optimize the performance of that workbook, Hyper is probably not the place where we should look for a bottleneck. Here, we would recommend to just address the general overall Tableau workbook performance guidelines and sessions that we have. But here I have another performance recording. This workbook takes 87 seconds to open, and as we can see in the very bottom, 37 seconds are spent executing hyperqueries. So Hyper is expensive, and probably there is something that we can do and that we show you in this session.
Right. So let's talk a little bit about self-service performance improvements, right? These are things you can do to make sure that Hyper can use all of the performance which it's so known for. And the very first thing we wanted to mention here is try and use clean data. And we also have an example of why this is important. A very basic example which we've seen, I think it's actually one of those 1,000-something workbooks which we regularly track, is something like this, right? It looks like a CSV, but you will notice that it uses $1 as a field separator, which is not very common, right? In older versions of Tableau, it wouldn't recognize $1 automatically as a field separator. So what you'd get is the thing you can see down there is basically one big text column with everything chunked together. To fix it, what you could do is something like this, right? We all know calcs. You can do a lot of things, magical things with calcs. This is probably not one of those magical things you want to do with calcs. You can just create your own types and say, OK, I want to split it by $. The first one, I know it's a date, and I'll call it order date. The second one, I know it's a float. I'll call it sales. The third one, I know it's a customer. And I'll just keep it as a string, right? But how does this perform? Because that's really what we're talking about here, right? And unfortunately, the answer is not very efficient. Why is that? Mostly because for every field, Hyper has to scan the input of the beginning until it finds that $, character, right? Type conversions, you have to do type conversions every single time, right? You have to take a string, check it, oh, that string is actually a date, check that date, and then convert it into a date. So as a lesson to this, the problem is that the field values are not first-class citizens in this extract, right? Because if we go back a little bit, this is what Hyper sees. Hyper only sees that one column, which is not optimal. So what you can do in this example real quick is just set the field separator to $, and as soon as you do that, you get a nice schema, and Hyper can actually use, so Tableau actually identifies those are dates and numbers you're talking about, and Hyper can store them as dates and numbers and more efficiently process them. So as a conclusion to this part, you should consider preparing your data. Tableau Prep is a very good example of how to do that. You can also use the Hyper API to clean data, and mostly because you can offload all of that work to one single batch work, which you only do before analyzing. Instead of paying that price of figuring out what types are and converting those one to each other, every time you query the viz, you can do it upfront once and then use clean data for your dashboards and visualizations. Other common use cases for preparing your data is to correct spelling mistakes, capitalizations, to do clustering, grouping, and you can also extend it to do things like machine learning or just apply some algorithms there to enrich the data, basically, to add more data to it.
Now that we make sure that we use clean data in our workbook, it's also very important that we make sure we use the right data types. Those data types sometimes can even be wrong in your source database. So in this example, I was connecting against the SQL Server, and I noticed that there is a date column. But as we can see, indicated by this little ABC on top here, in the source database, this is actually stored as a string, although it is a date. So when I create an extract from that, and I work with the date column, I at first would actually need to write a calculation, for example, to convert it into a date, which is inefficient. What you would need to do here is go to the data source pane, just click on that ABC on top, where you can see that string is actually being ticked, and hit datetime. And after that, create an extract from it. So you make sure that you have the correct data types in your extract, which will allow you fast analytics on it. There is another example that I have seen on a customer workbook. We have that simple sample data here. We see we got 3 columns, which represent sales data. The first column is called period. It's stored as a number. The second column is sales, which is also stored as a number, and we have a segment. So period is of the format 2019-01, which actually is meant to refer to the 1st of January 2019, and 2019-02 is meant to refer to the 1st of February 2019. And this is stored as a number. So if I want to do a viz on that, I would actually need to convert that number to a date. But there is no initial function to convert a number like this to a date. So we saw this as a solution to that problem. So what does this calculation do? At first, it converts the period into a string. Then it uses the tableau.left function to get to the first 4 digits. It uses the tableau.right function to get to the last 2 digits. It concatenates that via slashes. It appends a /01 at the end to refer to the 1st of the month, and then passes that to the Tableau date function. Now, how does that calculation perform? It could be faster. Why is this calculation not efficient? At first, we convert the number to a string. That's a rather expensive operation. Then we are doing string concatenations, which are also not for free. And finally, the most expensive operation in that calculation is converting that string to a date. So the conclusion we would like you to draw from that example is that you should use the native data type operations. Now, what are the native data type operations for that example? You could use a calculation like this. You can at first divide period by 100, which will cut off the last 2 digits and just give you the year. Convert that to an int, so it's get truncated. Then you use the modulus operation, which is indicated by that % sign with 100. That will give you the last 2 digits. And then you pass that with an additional 1 at the end as an argument to the Tableau make date function. So division and modulus are native operations for numeric data types, so they are much faster than string operations. And make date is faster than a string to date conversion.
And right now, I'm also, because we're talking about strings, I'm just going to go right in and talk a little bit about collations. So you guys probably don't know what, does anyone know what collations means? Yeah, I thought as much. So collations is basically a technical term that tries to describe how you sort strings. Basically, it says A is less than B is less than C is less than D, right? But it does so in a language-specific version, right? Because in some languages, you might have a different ordering. So John might come before Mary, or Mary might come before John, depending on the language. And why I want to talk a little bit about collations is it's one of the most, it has one of the largest impacts on performance in defects we've seen from customers so far. And the first thing about talking about collations is trying to describe why dealing with strings is hard and confusing. For instance, in Spanish, you have a special character N with a tilde on top. That's like the N in piñata. I hope I didn't mispronounce that or anything. And that is ordered between an N and an M. In Latvian, another example, you would have a Y less than a J. So if you're like me and you've done your ABCs in your head, just like thinking about it, yes, it should be, in English, it's the other way around. Danish has an A with a circle on top, which is a special character handled separately, which is totally different from an A. And it leads to very confusing things like a string with 2 A's does not contain 1 A, because those 2 A's together merge into something that's similar to this extra character, which is not in the English alphabet. In Turkish, you can the guys in the back probably can't see this very well, but there is an I with a dot and without a dot. So if you want to lowercase the I, the normal uppercase I we have in English, you would get a lowercase I but without the dot on top. And similarly, if you would uppercase a normal lowercase I, you would get the uppercase I with a dot on top, right? And then there's also like an interrobang, for instance, that exclamation mark followed by a question mark is also one Unicode character, but is that the same thing as the string consisting of the 2 Unicode characters? That's the kind of questions which collation has to deal with, and you can start and get a feeling about why this might be expensive, right? And this is not even the most important question. The most important question that keeps us all up at night with regards to collation is, how do I sort my emojis? Because obviously, laughing is less than crying while laughing, right? But don't worry, there's official documentation for that. You can check that out. There is an actual standard emoji ordering, which describes how all of your emojis should be ordered. So now that you know a little bit about it, what can you do about it, right? This is how can I make it better? The first thing, which we've already covered a little bit before, but I want to stress again, is try and only use strings if you need them, especially since you have to pay that extra price about locality, which you might not be aware of and you might not actually need. In the Hyper API, you can explicitly set it to whatever you want, to whatever you think makes sense, or even disable it completely. And you can also check if you actually need it. Most source databases will support changing it. If you change it in the source database, that would be the best solution because Tableau will pick that up and afterwards Hyper will pick that up as well. And if you change it into binary, usually all databases also have a special kind of collation called binary, which basically says, I'm not really interested about all these orders, just do what you would expect it to do, right? Just the letter A is equal to the letter A, and the letter A with a circle is like different, and I don't care what language it is. It's something that's a lot easier to process for database engines in general. And the second question to this is what we've done about it. We've already optimized several string functions. As a general rule of thumb, equality comparison and starts with, these functions will be faster, even if you're using collations, because we try and implement a lot of tricks to kind of like avoid all of that expensive computation if all you're using is just normal letters you'd find on your keyboard. And you don't really worry that much about all of those A with circles on top and whatever other letters you have. We've also done some language-specific performance improvements by using some clever tricks. Feel free to reach out for more details in a break or sometimes. For an example of this is Spanish. Most of this landed at 2018.2, but some were added later. Again, conclusion, use the latest version. We do try and fix things for you preemptively if we can.
Except for calculations, also filters can have an impact on the performance of your workbook. And one of the most common examples that we have seen, remember that one workbook that has been slow? It's usually been a workbook that uses row-level security. Row-level security is a use case on Tableau Server. And that, we have an example table here. You can see some sales data, order date, sales, customer, and segment. And at the end, there is an additional row-level security field. And that contains a concatenated list of users that may see each row. So for example, the first row, that may be seen by Jacob, Raoul, and Max. And the second row may only be seen by Raoul and Max. And usually, in order to be able to filter on that row-level security column per user, you would write a calculated field or that you use as a filter that just says contains row-level security and the Tableau username function, which will return you the name of the user that is currently signed into Tableau. So that normal use case of row-level security performs quite good in Hyper extracts. But we have seen customers reaching out to us that struggled with row-level security workbooks. So the uppercase that we see here works pretty efficient. But we had a customer who did not have one row-level security field. They actually had two. One row-level security field contained all the managers that may see each row, and the second field contained the users of each department that may see the row. So they were actually checking, is the user either a manager or is he just an employee in that department, and may he see that row? And that calculation with the OR performs less good, less efficient than if you only had that one calculation. And just to generalize that a bit, it's always efficient when you combine your filters with an AND. So when you drag a calculation or a row, column to your filter shelf, those are always combined with an AND, and that works efficient. When you're using a user-defined calculation and you use an OR expression, have like different restrictions that you want to apply, that is less efficient. Just to give you an idea of the basic concept, we don't want to go too much into detail. It's when you apply an AND, you're always restricting rows. When you have an OR, you will always have to check both fields because they do not necessarily mutually exclude each other. Now, after we explained that to the customer, what they did is they simply fused those two fields into one field. They were like, oh, now that we know it, it's no problem. We just adjust our custom ATL flow to just have one column instead of those two, and they were satisfied with the performance of that workbook. So that's the idea that we want to give you with that example. Now, staying again at the row-level security topic, there's actually a better way to do row-level security with Hyper. And in 2018.3, so approximately 1 year ago, we added a feature called multiple table storage for extracts. And looking at that table with the row-level security data again, we can see this field with these concatenated usernames at the end. Usually, that is not how it is stored in the database where you track your sales records. Usually, that would look something like this. You have one table that stores the sales data, and you have a separate table, a so-called entitlement table, that associates, in that case, a segment with a user. So we see the user Max may see consumer, corporate, and home office, and the user Raul may only see consumer products. And when you connect to your data directly with Tableau, you can drag in those two tables and use a join on the segment column. And then, when you create your extract, you go to, under connection, just to that little edit button, and in the extract data dialog, you choose multiple tables. As a result, Tableau will not store the result of that join, but it will preserve each of those tables individually in an extract. In order to implement that filter for row-level security, that would just be implemented as a data source filter, which is right next to the connection. Just add a new filter, go to custom condition by formula, and say user, which will actually refer to the user column of that entitlements table, equals the username function. And this will give the same effect as we had with that additional column at the end. Now, why should you use multiple table extracts? We recommend it generally to use when one table is very large and the other table is rather small in comparison. Row-level security is one example of that, but it could also be that you have like a dimension table with additional details of a product that you want to join to your sales data, which is also smaller than your actual sales data. The benefits that you get from that is faster extract creation, smaller extract file size, and in the case of row-level security, we usually expect better query performance. That is available, like I mentioned, since Tableau 2018.3.
Right, and now I wanted to talk a little bit about extract sizes and performance. What we're going to talk about in this section is mostly about how extracts and performance correlate with each other. And we're going to go through a few very common questions which we get asked by our sales consultant and our wonderful people in sales a lot. And the standard answer we always have to give them, but also explain why things are the way they are. So the first question, which a lot of people ask, is how big can my extract get, right? And mostly this question comes out of a misguided sense that I can somehow correlate the size of it with how fast my queries are going to be, how fast my visits are going to render. So here's where we get a little bit theoretically and say, okay, if you really want to know the theoretical limit, it's, yes, because of some reasons of how we store our IDs and things like that, you can have 500 billion rows, 4 billion columns, 4 billion tables, and each one can be a 4 gigabyte string if you really want to. So if you really go crazy in there, theoretically the limit could be something like 44 teradecillion bytes, which is a ridiculous number. How ridiculous? It's more than grains of sand in the Sahara and more than stars in the universe. So that's just like, but the important thing I wanted to come back to right now is the fact that extract size doesn't correlate with performance in the way you think it does. And there are some reasons why that is. The first one and most important one is that Hyper will only read the parts of the extract that is used in the workbook. In our experience, in our own online environment, we've seen that for big extracts, that can be as little as 20% of the data you're using. And this kind of starts to make sense when you think about how many columns you usually have in one of your extracts, and imagine that most of the vizzes don't really need all of them. You might just need like a third of them. And your filters might throw away another half of the data and things like that. So 1/3 by 1/2, you're already approaching that 20% right there. The second reason why it doesn't correlate the way you'd expect it to is because file size has no say. So that's not totally correct. It does have some say, but it's not as much as you expect, because Hyper compresses the values by using dictionaries, short string compression, truncation, small numbers, things like that. And we also use LZ4 compression afterwards. So because it's already compressed, it's not necessarily a good indicator of how many rows you have in there or how much data you're actually going to process. What does correlate better with performance, though, is your workload. So if you come back to that one question, a better question would have been, what's the biggest extract that Hyper can practically handle, right? And the answer, it totally depends on your machine. And just so that we aren't always vague, the largest extract we test with is about 670 gigabytes and has 1.5 billion rows. You can already imagine at those sizes you would have problems all throughout the stack already. Just think about backup times, how long that'll take to upload to server and things like that. So the good news is Hyper can handle large data. The second part of that is coming back to that letter which Max read earlier. How do I size my hardware? Like what hardware does Hyper need? Do I buy more RAM? Do I buy more cores? Do I need SSDs? Do I need hard drives? Do I need the latest? Do I need the greatest? Things like that. But short answer is, like always, it depends, right? And here, again, taking online as an example, we already have workbooks that are specifically designed to hit Hyper hard in different areas. We have one workbook that hits it in CPU, one workbook that hits it in memory, and one workbook that hits it in input-output, or your hard drives. And that's mostly because Tableau can be used to do so many different and varying things. And the calculations themselves are so powerful, you can just tailor workbooks to hit specific issues like we did, right? But the best answer to how you can actually fix it is to stage it. And here's where I talk about an experience I had in TC last year, when I had a customer come up to our booth and just telling us, he was all excited and saying, oh, hey, you guys are from Hyper. I love Hyper. It's fast, it's awesome, it's amazing. But it still takes me a few seconds to process my, I don't know how many million row workbook. I'm this close to going to my IT guys and telling them, I want you to buy me 1 terabyte of RAM. It's going to make things faster. I know it. I want you to buy me 1 terabyte of RAM. And then we talked a little bit about it. It's like, okay, why are you sure you need RAM? Well, it's like, maybe hold off a little bit. It's like I said, right? It could be CPU, it could be memory, it could be I/O. I'm not sure that RAM is actually going to help you. And then while talking, he actually told me, oh yeah, while it was running in the background, I just fired up Task Manager. And what I saw is memory was always high. And after a few seconds, it started writing out to disk as well. And that's when I realized that sometimes just staging to try and figure out what your bottleneck is could be as easy as just starting Task Manager and just looking at what Hyper is doing while that spinner is loading there in the background. So as general guidelines we wanted to give you for this, Hyper, we've tried to design it in such a way that it will scale with all the resources you give it. So the more resources you throw at it, the faster it's going to process your queries. 100% CPU is usually a good thing. Sometimes it can signal stuff we could do more optimally or calcs that could be written better. But as a general rule of thumb, if it uses all of your processors, that's a good thing because you don't want your processors to just sit idly and do nothing. If you have high memory usage, it could mean you're memory bottlenecked, especially in this example I gave previously where he saw large memory usage coupled with disk writes, because Hyper will start to switch to disk if it doesn't have enough memory. And another example is that low CPU and memory usage and your queries are still slow. It could mean your disks are slow to read. You should consider upgrading to SSDs. Or in one example we had with a customer, it actually looked like a busted RAID controller because it would always burst pretty fast and then at randomly read performance would just like plummet 100 times. For anything else, as always, feel free to reach out. We're always super happy to optimize. We're also very passionate about making sure it does scale with your resources the way you want it to. So if you do find something that isn't covered, we'll definitely love to take a look at it.
So finally, let's look a bit into hyperlogs to get a bit more intrinsically. You will find the hyperlogs. So what we show you here can be applied to the hyperlogs from Tableau Server, as well as the logs that you get from Tableau Desktop, from the Hyper process on Tableau Server or Desktop. There is a very handy tool available on GitHub, which is also partially maintained by our team, that you can use to analyze all Tableau log files. This is the Tableau log viewer. You will have it available on, when you search in Google for it, you will find it. And when you take a look at a hyperlog with Tableau log viewer, this is just the basic structure of what a hyperlog looks like. And let me just walk you through that log message. So in a hyperlog, we have one event per line of the log, and each event looks like that. We have some general information in a log event. This is TS, which stands for timestamp, PID, which stands for the process ID, and TID, which stands for the thread ID that has been logging the event. So that is some general information that helps you to identify when the event happened and which process it was. Then we have a field which is called severity. That is used to indicate how important a particular log message is. So watch out for warning, error, or fatal. Those will indicate that there has been something gone wrong. Then we have request, session, and context. Those are used to track an event across multiple log entries. So if you just follow request and session within one Hyper process, then you will be able to observe a query all the way from when Hyper received the query until it has been processing it and sent the result back to the server. The client context is also present in other Tableau logs. So that helps us to track an event between a Tableau log and a Hyper log. And finally, we have K, which simply stands for key and indicates the event that has actually been recorded. So we just sum up 3 of the log events that we consider the most important ones. On the one hand side, that is query plan slow. For queries that take more than 10 seconds to process, we log the query plan. It's like when you're a bit into database systems, understand how query trees look like, then this is gonna be interesting for you if you're like investigating a performance bottleneck. You see the plan how Hyper would actually process that query, including joins and information like that. Another log message is the spooling fallback. That indicates actually the event that Raul described from that one customer, where we saw a high memory usage and disk writes at the same time. I'm pretty sure if we had taken a look at the hyperlog of that customer, we would have seen a spooling fallback log message. So when you see spooling fallback, that may be an indication that your RAM is at its limit. And finally, we have the query end log message. That is just generally logged for every query that has been processed by Hyper. And this is the information that you can get from the query end log message. You get the elapsed time. So when you have a slow workbook and you already know that you have heavy hitter Hyper queries, you can take a look in the hyperlog at the elapsed time to identify those heavy hitter queries. And then there are some more detailed timing informations that you can get. On the one hand side, we have the execution time. That shows only the time that Hyper has spent executing the query. There are several phases to processing a query. At first, Hyper receives it, then it is being parsed, it is being optimized, and then it is executed. Execution usually is the largest time that is taken in a query. Then we have the CPU time. That is the time that this query has actually been processed on your CPU. And the CPU time could actually be higher than the execution time because we count that per core. So when you have a machine with 4 cores, it may be that your CPU time is up to 4 times as high as the execution time. Finally, we have storage, access time, access byte, and read bytes. And the storage time, that actually helps you chase down how much time Hyper has actually spent reading data from the disk. So in that scenario that Raul described, where you saw a low CPU usage and a low memory usage and slow queries, it might be worth looking at the storage access time of Hyper query end log messages to see how much time has actually been spent reading data from storage. And then you can, for example, see what is the relation between those and see if that what is actually being bottlenecked by those particular queries that you're using. And finally, we have time to schedule. That is rather interesting in the context of a Tableau server. It shows you how much time the query has been waiting after it was received until Hyper could start processing it because it had to wait for other queries to finish first. So if you have a really, really high time to schedule, that can be an indication that your Hyper node is overloaded.
Right. And we're coming into the conclusion of our talk, just 2 minutes shy of when we actually wanted to start the question, so we're doing really well on time. And we try to summarize what we've talked about in this talk in a checklist, right? So if you look through this checklist, just top to bottom, what should I be doing when I'm worried about Hyper performance? Step 1 is always check, am I using Hyper? Is it a Hyper performance issue? Do I even need to continue looking into this list or not? The second part is query execution actually the dominating factor, or am I just spending time connecting to the database or parsing XMLs or doing other things? Did I already make sure to try the latest version? Maybe I don't even need to do anything, just bother my admin to upgrade. Am I cleaning data in my workbook? Should I be doing that? Maybe I can just do it before in prep. Am I using the right data types? Then if I am and it's still slow, I could start thinking about, am I using collations? Do I need collations? Can I turn them off? Can I optimize my sheet in general, right? Can I make my calcs better? And if not, should I be using multiple table extracts? And then at the end, if not, and I still see problems, and I've run through all of those, should I invest into more hardware? Because maybe my hardware just can't keep up with what it has to process. And if everything else fails, or even if you think something doesn't add up and something is fishy, always feel free to reach out to us. So please complete the session survey in the mobile app. This is how we make the talk better and how we know if you guys liked it or if you guys think it sucked. And without it, we can't really get any better. You can find it there under my evaluation, and you can find a session under schedule. And now we also have some time for questions if you want.